In this video, we will learn about Newton's laws. Newton's first law of motion states that every body continues to be in its state of rest or of uniform motion in a straight line unless and until compelled by any external force to change its state of rest or of uniform motion. Applications of first law of motion: when a running horse suddenly stops, the rider falls forward. When a horse suddenly starts moving, the rider falls backward. When the carpet is beaten with a stick to remove the dust, athletes run some distance before taking a long jump. A man jumping from a moving train may fall down. See, a block is there on the table. The block remains at rest unless and until it is acted upon by an external force. So to move all these, we require some force. Otherwise, the body will remain in its state. Either it is of rest or of motion. Momentum. It is the quantity of motion contained in a body, and it depends upon mass and velocity. Mathematically, it is the product of mass and velocity. Momentum is directly proportional to mass. If a cricket ball and a tennis ball move with the same velocity, momentum of cricket ball is more because its mass is larger than that of the tennis ball. Momentum is directly proportional to velocity. If two cricket balls move with different velocities, then the momentum of the ball with greater velocity possesses more momentum. And if the body is at rest, its momentum is zero. But every moving body possesses momentum. Momentum is a vector quantity and its SI unit is kilogram meter per second. Some facts about momentum. Velocity and momentum vectors point in the same direction. It is a conserved quantity. We will prove it later on. A net force is required to change the body's momentum. Something big and slow could have the same momentum as something small and far. See, there is a bus and a car, and both have the same momentum because there is a change in the mass and velocities. So there is a difficulty in bringing the vehicles to rest in terms of the combination of force and time required would be the same because they have the same momentum. Now, importance of momentum for considering the effect of force on the motion. Suppose a light vehicle and a heavy vehicle are parked on the horizontal road. So a greater force is required to push the truck than the car to bring them to the same speed in same time. Similarly, a greater opposing force is required to stop the truck than the car if they are moving with the same speed. Similarly, a bullet fired by a gun can easily pierce human tissues before it stops, resulting in casualty. and the same bullet with moderate speed will not cause much damage. Thus, for a given mass, greater is the speed, greater is the opposing force needed to stop the body in the certain time. So this, we can say that the same force for the same time cause the same change in momentum in different bodies. And the force not only depends on the change in momentum, but also on how fast the change is brought. Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction in which the force acts. Mathematically, force is directly proportional to change in momentum upon time taken. If force F changes the velocity of a body of mass m from v to v plus delta v, then its initial momentum p is equals to mv will change to by delta p is equals to m delta v. And according to Newton's second law, F is directly proportional to delta p by delta t. When you remove the directly sign, you will get a constant, and that is k. Or we can say that F is equals to k into limit delta t tends to 0 p by delta t. And that is equivalent to F is equals to k into dp by dt. So F is equals to k into d of mv. Replace the momentum by m into v. Mass is constant, so you got k into m into dv by dt, and you know that dv by dt is acceleration and the value of k is 1. So F is equals to mass into addition. From here, acceleration will be force upon mass. And the SI unit of force is Newton. And 1 Newton is defined as the force which, when acting on a body of mass 1 kilogram, produces an acceleration of 1 meter per second square in it. And in the second law, means in equation F is equals to ma, if F is 0, that means A is 0. The second law of motion is the vector law. It is equivalent to 3 equations, one for each component of vectors. Means the force along x-axis will be equals to the rate of change of momentum along x-axis only, means max. Similarly for forces along y and z axis. Any internal forces in the system are not to be included in force. Now, impulse. When a ball hits a wall and bounces back, the force on the ball by the wall act for a very short time when the two are in contact. Yet the force is large enough to reverse the momentum on the ball. In this situation, it is difficult to ascertain the force and time duration separately. However, the product of force and time, which is the change in momentum, is a measurable quantity and is known as impulse. Impulse is equals to force into time duration mathematically, and that is equals to change in momentum. It is denoted by J or by I in some books. Large force acting for a short time to produce change in momentum is called impulsive force. Importance. A high jumping or long jumping athlete is provided either a cushion or a heap of sand on the ground to fall upon, because that will increase the time period. The cushion or sand helps to increase the time and the momentum comes to 0. This decreases the rate of change of momentum and hence the force. so the athlete doesn't get hurt. Similarly, the packing materials like thermocol or bubbled plastic sheets, etc., to save the packings of glasswares, chinawares, etc. Because these materials will help them to increase the time in which the momentum comes to zero.